Hey everybody, it's Mr. Odom, and today we're going to look at some problems from section 3.1. And so the learning target for this video is hopefully at the end you'll be able to say confidently that you can identify terms and like terms in an algebraic expression. So remember, chapter 3 is where we really start to think about things in an algebraic way, which just means there's some variables, there's unknowns, and we're going to do some math with those variables and unknowns. But first, we have to be able to look at an expression and pick out parts of the expression that we can combine. And those things that we can combine are called like terms. So you need a pencil, composition book, or notebook paper. You won't need a calculator for this one, but if you have one handy, that's always a good thing. So we'll jump right in. So for these problems, 6, 8, and 10, we have to identify the terms and the like terms. So what I like to do, and all we have to do is just list these things. So for each problem, we are going to find the terms. Let's do that first. So the terms. And what I like to do is just circle them or put a box around them. Actually, let me erase this because I want to do that first. So let me write this first expression down. 3z plus 4 plus 2 plus 4z. Okay, and I want to identify the terms. So the terms are 3z, here's one term, here's another term, 4, and I'm going to include, when I put that circle around there, the sign, and you'll see why when we start to combine like terms later on. So this term is positive 4. This term is positive 2, and this term is positive 4z. Now in front of the 3z, there is no negative sign. So there is no negative sign there. If there was, this term would be negative 3z. But since that's not there, this term is just 4z. So let's list these terms. And here we go. 3z, put a comma, positive 4, put a comma, positive 2, and then positive 4z. All right, now let's look at what the like terms are. Remember, like terms are terms that, let me see, I'll just read the definition to you. Like terms are terms that have the same variables raised to the same exponents. Okay, so that's what like terms are. All right, so let's list these like terms. Well, I'm looking for terms that have the same variables raised to the same exponents. Well, here I see 3z and 4z, and they are raised to the first power, which we don't have to write there, but I could if I wanted to. So these are like terms, 3z and 4z. So there's a pair of like terms. That's important to be able to identify these things in an algebraic expression, because then we're going to learn that we can actually add these two like terms together. Also, constants, like the number 4 and the number 2 are constant. They don't change. 4 will always be 4, 2 will always be 2. So constants, all constants are like terms, 4 and 2. And we already know we can combine 4 and 2 if we need to. We could add them, we could subtract them. All right, so these are the like terms. This is a set of like terms, and this is another set of like terms. All right, so armed with that, let's look at number 8. Let me write it down. Negative x minus 9x squared plus 12x squared plus 7. All right, so let's identify the terms. All right, the terms here are negative x, that's a term. Negative 9x squared, that's another term. Positive 12x squared, 12x squared, and the last one, positive 7. All right, let's see if we can find the like terms. All right, so for like terms, what do we have? Well, negative x, there is no other term here that just has an x as a variable. Okay, so there is no like term that goes with negative x. What about negative 9x squared? Well, there is another term that has an x squared variable in there. So negative 9x squared and 12x squared are like terms. 7 is a constant. It's just a number. Are there any other constants in this expression? There are not. So the thing about like terms is there has to be at least 2 terms. Okay, this is plural, like terms. Okay, so this is the answer. These are the like terms in that expression. All right, number 10. Let's see, 1/2 s minus 4 plus, actually, I'm going to do this one differently. Let's just see if we can look at the problem, and let's just see if we can identify the terms and then the like terms without having to write it down. So I go here, 1/2 s, that's a term. Negative 4, that's another term. 3/4 s, that's a term. Positive 1/8, so write 1/8, and negative s cubed, negative s cubed. So you notice I can look at an expression and I can write these terms down. Now, what about like terms? Well, 1/2 s and 3/4 s. Those are like terms. So let me write that down right here. Like terms. So I have 1/2 s and 3/4 s. Those are like terms. They have the same variable raised to the same exponent. Are there any others here? Well, negative 4, that's a constant. And 1/8, that is also a constant. So these are like terms. All constants are like terms. So that takes care of these two. What about the negative s cubed? Well, there is no other term that has the variable s raised to the 3rd power, so there is no like term that goes along with negative s cubed. So then I'm done. I've identified the terms and the like terms. So hopefully that video was helpful. If you have questions, remember, bring them to class and I will answer them for you. But this is Mr. Odom. I'm out. Hope you guys have a good day. You're awesome.